This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 137. Wow, what a great number of satellite book clubs we've had. Thanks, everybody, for joining us. Happy spring. And today we're going to be talking about the Spring 2022 Red River North Basin flood event. Our presenter, William Straka, researcher at the Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin-Madison. Our facilitator, Dr. Adrian Lopez, meteorologist from the Weather Service Forecast Office in Louisville, Kentucky. As you just heard, this session is being recorded. There will be an opportunity for Q&A after the presentation. We particularly encourage questions from our field offices and regional headquarters. Please post your question in the chat or note that you would like to ask your question verbally, and we will certainly accommodate that. Also, if you are signed in with an office account, please note your full name when asking a question so that we can get back in touch with you if needed. And if you're looking for TowerS communications, you thought you were getting them in the past and you're not getting them anymore, check your spam folder. Unfortunately, some communications are ending up there. We're always looking for future presenters, particularly from our field offices. If you have a presentation perhaps you gave at a AMS, NWA meeting or a regional conference, it doesn't even have to be completely related to satellites, but maybe you just use satellites as part of a case study, contact the TowerS team. We'd love to have you present. And the training team can help create training materials that may be unavailable or point you to materials you may be unaware of. Brian Mott at the Office of the Chief Learning Officer can help with that. I'd like to thank our TowerS team, particularly Kashad Bowman, Lee Byerly, the Office of the Chief Learning Officer, the GOES-R and JPSS program for their support of the Satellite Book Club. Of course, thanks to all of you and our facilitator and our presenter for today. Without further ado, let me introduce William Straka, who's been a researcher at the Cooperative Institute for Meteorological Satellite Studies at CIMSS for nearly 18 years. Currently, he focuses on a number of topics, including algorithm integration, utilization of the day-night band, or DNB, on VIIRS, as well as, for the last several years, interacting with forecasters and other stakeholders on utilizing flood and other satellite products for disaster monitoring and response. With that, I'll turn it over to William. Looking forward to your presentation today.
Thank you, Jordan. I do want to acknowledge Carl Jones of the Grand Forks Forecast Office. He's on here today. He's notionally the primary author, but good interaction. We've done a lot of good interactions during the last several years up in the northern part of the United States, in North Dakota and the Red River Basin. And this topic, actually, we'll be talking about, expanding remotely sensed products used in operational decision support services during the 2022 spring flood event within the Red River North Basin. There's also several other collaborators from Noah Nesdis, as well as Sam Lee, who is the algorithm developer. So I'm just going to give a brief overview of the 2022 flood timeline, the impacts, and then get into the usage of satellite and other products during decision support services during the flood event, and then just, of course, a brief summary. So for those of you that may not be familiar with the Red River Basin, it's a transboundary river that actually flows from the south to the north. It's pretty unusual for a river in the northern hemisphere to do that, but it flows downstream into Canada. You can kind of see where Grand Forks is down at the bottom and Winnipeg, Canada up there at the top. You can see there's a lot of different types of land, cropland, forest, and in the area that can interact and depend on how and change how floods occur. So there were some antecedent conditions going into the spring of 2022. I want to thank Carl for these nice diagrams. They're very nice and clear of showing how things were. So During the fall of 21, there's very dry. They were in a drought, and that basically would allow snow water melt to infiltrate the ground as it thawed. There was, of course, then a deep frost layer with frozen waterways because it was a very cold winter. And then there was a very extensive snowpack with some abnormally high snow water equivalents from a very active 2021-22 season, actually somewhat similar to this season as well. But in the case of 2021-22, there were numerous blowing snow events, which led to some highly variable snow depths and snow water equivalents within the snowpack. Of course, then mid to late March, so about this time last year, there was some warming, which melted most of the snowpack in most of the places very quickly. Since the ground frost layer lowered, that allowed that water to infiltrate the ground. There was minimal jamming issues. There was some rising, but it was not. There was not very much impact, and this is probably because of that infiltration of the dry thawed soils. Then early to mid-April of last year, there was another round of abnormally cold weather, which slowed the thawing of the ground soils. In addition, there were several precipitation events, again, with a fairly major blizzard over the course of a couple of days that led to about 12 to 24 inches of additional snow. But then there was also rainfall that was on top of it. So there was about 1 to 4 inches of new precipitation, snow water equivalent that was added in that short period of time. Of course, the top layer of the soil was very saturated at the time because it was already, so there was still, there was some response in the rivers, but there was still a lot of snow that water that was locked up in the fresh snowpack. Then in late April, there was yet another record-setting rain event, in addition to several other heavy rain events in early May. And the warm temperatures, along with the heavy rain, very rapidly melted the April snowpack. It was about less than 7 days. So now all the soil was completely saturated, and all the melted wind meant the water had to go somewhere. So that led to a rapid rise of river and flash overland flooding ensued. There were many, all these impacts, there were several bouts of flash flooding over in eastern North Dakota and northwest Minnesota, and actually lasted in through June. But there was a major proactive flooding along the Red River, as well as the tributaries. This allowed for prolonged high water and flooding impacts along the Devil's Lake area in North Dakota and Lake of the Woods, Minnesota. There was also a lake that formed in a place that shouldn't have been a lake near Oslo. I think it was notionally dubbed Lake Oslo at the time. Created for some very interesting features. If you looked at the GOES imagery, you could actually see a lake effect on a lake that didn't normally exist. So some interesting meteorological things that occurred as well. It was actually the river in Penumbra actually ended up on the 3rd highest crest on record. And as you can see, there was over almost 2 months of days in flood and over a month in moderate flood conditions there. Numerous bridge washouts, road closures, including Interstate 29, which is a major commerce, major highway for commerce, inter-country commerce between the United States and Canada. There were a lot of towns that were inaccessible. In fact, in Canada, there was one town that had its flood mitigation from previous storm completely surrounded by water. Flood mitigation worked. The town wasn't flooded, but people couldn't access it. Of course, with agriculture, there was delayed in planting. Sometimes, in some cases, they weren't even able to plant for the 2022 growing season. So, there's had to be a shift in crops. And of course, other infrastructure and commerce impacts like damage to dams and loss of tourism. There was this meant that there had to be a lot of collaboration, interagency collaboration, not with the National Weather Service and the North Central River Forecast Center. This was done via virtual meetings between the forecast offices and the RFCs, and they talked about, the status of the snowpack, the river and ditch ice, and the areas of standing or flowing water. And as part of this discussion, satellite analysis was used as the main content for discussion. And there's a screenshot there from one of the meetings on the 19th of March, where the flood product was actually being shown and discussed at that meeting. Of course, they discussed other information such as river gauge information, ground and aerial observations, and stream flow models. So which were filling in the key pieces of those are key pieces of information that filled in the gaps that satellite data couldn't provide. One example topic is just to, if you looked at the ABI flood extent, you'll see the animated GIF here as it goes around, suggested there's a lot of standing water over the land. However, if you utilized the VIIRS product, which is now operational, along with Sentinel-2 high spatial RGB imagery, you could actually see there was actually very little flood water. And so this is the sort of valuable information that is used to assess for potential impacts, such as how much water was remaining and available to enter the water system. So that gave them, the forecasters, confidence, increased confidence in that the flooding at this time was going to meet the lower forecast percentiles. Remember, this is March, so it's before the big snowstorm that happened in April. As we go further into our timeline, the May timeline, when we started having the major flooding, you can see the rapid onset of the gauge height there on the right. They were noticing that the Penumbra River in Northeast Dakota was flowing higher and longer than it was forecast. And of course, the Weather Service and the RFC wanted to know, well, why is this happening? This is because there were dams that were full or overflowing their emergency spillways. And so there's this real desire to understand where it's coming from, and is there more water that's going to prolong this flooding. And so one of the tools that was used was you have Sentinel-1 SAR data, RGB satellite data, that you can see in a two-dimensional field of, okay, there's water. But the idea, it's important to know where that water is going to flow. And so part of that is to access the data in a three-dimensional perspective. So to understand the water is sitting at a higher elevation with a steep decline into the Penumbra River, as well as into the sensitive dams. And so that means any of that existing water or new water would travel through this area and then go more swiftly and as compared to the rest of the basin, and that then increased potential for higher impacts in that particular area of the Penumbra River. And of course, there was a lot of international and interagency collaboration, not just within the Weather Service, but also with agencies such as FEMA and the state of North Dakota for impacts on recovery efforts and assessments of damage. And of course, since it is, as I mentioned, it is a transboundary river with flowing into Canada, there is interactions with Environment Canada and Natural Resources Canada. And Natural Resources Canada also does provide routine radar constellation mention data. That's actually it's a 3 satellite constellation of synthetic aperture radar satellites. So provides higher temporal refresh than Sentinel-1, which currently is only 1, but the next one, Sentinel-1C, is actually notionally planned for launch in April. So there will be 2. But again, it has a lower temporal latency than the RCM data over over Canada and North Dakota. So in summary, the historic Red River season was a result of a number of factors, including a dry fall, frozen ground, and then very intense snow and precipitation events. During the flood event, there was a wide range of remote sensing that was utilized to observe the impacts, including satellite data, aerial imagery. I think there was some drone imagery as well as the river gauges. And the satellite imagery, along with all the other data, was utilized to provide decision support ranging from quantitative, determining the satellite quantitative signals, as well as verification of the flood extent products. And it's the combination of these tools and the training and the operational knowledge that provide these highly reliable forecasts during flood events. And one thing I do want to mention is that as I mentioned, the VIIRS flood product is operational now, and we are TowerS has been working with a number of forecast offices, including Grand Forks, Louisville, and Western Region headquarters, as well as many others, to serve as sort of test sites for the product. And also the Alaska Pacific office up in Alaska doesn't use the operational feed just yet, but they have been using the flood product for many years now during their breakup season, which is just starting in the next month or so. For other offices, while the rollout process is occurring, you can access these products on the internet through a portal that has been developed, and I think Adrian was somebody's going to post the link there. That's another way of accessing these data. So I think with that, I think I have plenty of time for questions.
Thank you so much, William. We appreciate your presentation. And thank you all for attending William's presentation. I just shared the link on the chat in case you want to check it out. All the resources are listed there. You have to do a little bit of search through the website, which I think is very helpful because you'll find more resources as you go on. So I will please ask attendees to stay for the Q&A and discussion section. I will encourage the field forecast offices and regional headquarters to actually provide feedback if you all have used these products, and I will in a little bit. And if you're gonna say or stay some questions, please stay, as Jordan said, your full names on the chat so we can, afterwards get back to you if there is any pending issues that you wanna keep, finding about. Lee Barley just posted a short survey on the chat in case you wanna leave some feedback for the Satellite Book Club for us here, and we'll, take care of it. Any comments, feedback. Remember that next week, April the 6th at noon Eastern Time, 11 Central Time, Bill Line and Liz Klein from the GHOST program and Nestis Star will discuss the GHOST 18 barcode artifact. And if you feel like you have something to say on our Satellite Book Club and you want to present, or you want to get to Lee Barley or Kachuk Bowman about, for example, configuring any satellite products, please contact the TowerS team, and you have the contact links on screen right now, or you can, also chat the TowerS team using the NWS chat, and it is also displayed on the screen right now. So if you have any questions, any comment, feedback on the product for William, this is a good time, and we are gonna start right now. So please feel free to share them. Well, William, I don't
Yeah.
see any comments so far, but okay. Okay, so we do have one comment from Andrew Orison, and the question is, my impression is that the ghost flood product did rather poorly with the real-time depiction of flooding relative to the VIIRS Sentinel data. Is there really a confident explanation for this? Is it just spatial resolution on its own? William?
Yeah, the answer is actually it is spatial. It is primarily the spatial resolution. You know, the VIIRS product is 375 meters, while the GOES one is 1 kilometer, and of course, the further north you go, that 1 kilometer is not really 1 kilometer. That's why the GOES product actually cuts off just north of the U.S. Canadian border. So, but it is primarily due to the resolution between the two products that you get that biggest difference.
Thank you, William. Scott and Bill are asking you, William, about the prognosis for the Red River this year, actually. How does it look
Yeah,
this
and
year?
I thought that I saw Justin answer the question there, and yeah, it's mostly summer, and there's a lot of water in the snowpack, and I think if I remember the numbers right, it's over 90% chance of a moderate to major flood. But of course, you know, that could all depend on the big factor is, of course, how quickly that snow melt will happen. If you get a long protracted melt, you know, you have less of a risk than if it's, oh, I got a big rainstorm that melts everything off and you know, melts everything off all at once. You know, you don't want to, you know, it's really you know, question it's really a question of how that spring thaw will occur. So
Sounds good, William. And thank you, Justin Palmer. And on the chat, he also kind of like answered that question similarly to you, William. Thank you, Justin, for that. I will also mention that, and correct me, William, if I am wrong, that in the Real Earth page or website that you will find that reference on the link we shared previously. One, advantage of GO16 is that it provides more temporal resolution. So you have the product every hour, William, if I am not mistaken.
that's right.
So, I mean, that's one advantage of VIIRS, that it's not that high resolution, but you'll have more updates and you can get like
Yeah,
the first
yeah,
guess picture.
yeah. The ABI product actually is currently, well, I guess you could say technically still in research mode. I use that research as loosely because it's actually in the process to become operational in the next few years. So in the next few years, they'll be rolling out the ABI product into the AWIPS2 terminals as well. But yes, the idea of using the ABI instruments GOES 16 and 18 is to sort of get, we'll call it a first look as the day goes on about what things are what's happening, and then of course you further refine that with your polar orbiters, the optical instruments, which of course, I mean, the opticals of course are limited by clouds, but you know, when you get the passes, that you further refine that, and then when you have the availability of synthetic aperture radar, you can add in that. And I will say one of the projects is also to utilize the SLSTR instrument on Sentinel-3 to help fill in the morning gap, and hopefully we'll also be able to be funded to use the EPSSG satellites to also fill in the morning orbit. So rather than just waiting on the ABI. But yes, it does, as Andrew mentioned, it is correct that you do need to cross-check the GOES data with the other with the other higher resolution sensors.
Right. And William, I do want to share my kind of like my experience so far in Louisville, putting or checking this product for a few days now. It was, initially a very seamless, addition to our AWIPS. Lee Barley or Chuck Bowman will help you with that. And I passed that to our ITO in the office. And for the Ohio Valley, if I am not, mistaken right now, it will be the Northeast Basin in case you are interested in getting, because there are several basins, right? So for the
Yeah,
Ohio Valley.
they're rolling out. You can subscribe. If Lee'll probably correct me if I'm wrong, but if I'm right, you can get you can you can get the basin that you need. For example, if you don't need the Western basin, you don't need California. You wouldn't download it, of course, but you could download the basin that you're interested in. Yes.
Exactly. And for the Ohio Valley, as I was saying, was the Northeast Basin, if I'm not wrong. So that was a quick install or addition to our AWIPS. And I have been, I checked the product Saturday and Sunday, last Saturday and Sunday. And I quickly find out that, in our case, it was detecting flooding, because I don't know if this has happened to any of you in the field offices and operations. Sometimes we receive some like MPIN LSRs saying that there is a creek or overflowed or flooding in some barns or basements, and we check, the hydrographs in the AHIPS website. I don't see any river going into flooding, and I always guess or wonder when, where is this happening and why? And in this case, for Saturday and Sunday, after the big rain that we had on Friday here in the Ohio Valley, and I checked the product, and it was giving me flood, right next to the Rough River in the Muddy Creek, it is called, between like Beaver Dam and a town that I don't remember right now to the north. And I sent this email to William, which is, by the way, very responsive if you have any questions. But anyways, I checked the product and it was giving me flooding where there was no actual river gauge. So I think that's a very useful, application of this, like, at least VIIRS, that it detects this flooding where there is no river gauge. And I guess, like, well, and I had to like totally go to Google Maps to actually overlap, the VIIRS product where actually that, Muddy Creek was. And I kind of like, the only thing that I need right now is confirmation that there was actually flooding. But since there is no river gauge, I will have to call an EM and actually talk to the people around that, that area to see if there was flooding or there is usually flooding in that area, just to complement the information from VIIRS and actually verify that, this is another, application of the VIIRS flood product. Whenever there is no river gauge, you can, say, well, there is flooding here. At least there are like 2-3 houses that might, experience flooding if this happens. And it is all detected by VIIRS. So appreciate that.
Yeah. And we've also been working with the Western Region headquarters in response to the California floods, which I'm sure people have heard about. One of the things I'll say an unintended, but I kind of was thinking we might see it, the unintended thing we observed was that the governor of California instituted a executive order to basically allow fields to be flooded intentionally. You will see flooded fields in the product when they're moist, particularly if they're moist. But anyway, they were intentionally flooding these fields to help recharge the aquifers there in California, which I'm sure people are aware have been very depleted over the last several years. So it was a confirmation that people were doing, we actually had some other open source material from the media that, actually took pictures of this activity as well. So there's many different aspects of flooding that that you can receive confirmation on from the satellite products.
William, I do have 2 questions. The first one will be for you. Is there any seasonality with this product between, like surface temperatures between like winter and summer, for example? Do you see any changes in the flood map extent because of
Well,
the temperatures?
of course, if it's flooding, you'll see if it's above freezing and there's flooding, you'll see the you'll see flooding occurring. And when it's winter, it's actually one of the area one of the values is for snow and for ice and for, we'll call it super snow. So if it's snowing, you'll see this, snow, you'll see the snow there. One thing, of course, to be aware of is as snow melts, you'll see moisture in the area of snow melt. But again, you kind of would expect that, as you melt, you're going to see water. And more so in Alaska, but even in the continental United States, there are areas that do get ice jams. And so sometimes you can see the ice jam itself, where they get the flooding. Maybe cold out, but you get somewhat cold out. You see flooding as a result of that ice jam. You'll also see you will occasionally see the overflow water along some of the rivers. It'll pop up. It won't pop up as water, but it'll pop up as the super ice value. And so it's not really a problem unless you're a truck driver, an ice truck driver, or your snowmobiler trying to go along the river. But those are features that you do see, and we have seen, not just in Alaska, but even in the continental United States, regarding the seasonalities.
Thank you. My second question is there any case that you remember with like tropical cyclone flooding and like accumulating water, like, like precipitation? Is there any case like that?
Well, I was gonna say, I just point back to Hurricane Ian of last year, where we had, obviously there was large flooding going on along in Florida that we've seen. Usually it's after the storm has passed, but that's a very poignant case. We actually, I forget which year it was up in New Jersey. There was I just went blank on the name of the river, but it was a very major, it was a very major flood. It was of course over national news that the flooding that had occurred. That of course, was as a result of I'm gonna forget the name of the storm. A lot of storms have happened, but yes, we've seen that over, over pretty much the entire Gulf region, from the Gulf, from Texas all the way over to the Florida Panhandle and down the Florida Peninsula. In fact, one of our test offices is in Corpus Christi. They've also been one of the offices that have used the product after hurricane events as well. Yeah, doesn't say, it's probably Hurricane Ida.
Yeah.
Too many storms meld into your name, into your brain sometimes.
It is. It has been active.
Yeah.
If someone else wants to like chime in and ask any question, you're free to go and do it. We'll give like a few seconds here to see if there are more questions. Well, I appreciate everyone for participating in this Satellite Book Club seminar. Thank you, William, for your presentation. Thank you to VIIRS, and thank you to you, Jordan. I'll get back to you now.
All right, thank you, and thanks to everyone for being with us today. Just keep in mind that the Satellite Book Club continues each and every week. So next week on Thursday, April 6th at 12 noon Eastern Time, we're going to hear from Bill Line and Liz Klein. And also, if you need to reach out to the TowerS team, please contact Lee Byerly and Kashad Bowman for anything regarding the book club or the configuration of satellite products in AWIPS. All right, I think we're going to leave it there for today. As I said, thank you so much for attending. Thanks so much to our facilitator, our presenter, and our TowerS team. and hope to see you again next week. Take care, everybody.